All right, so let's actually run this code now in the mode where we can visualize the objects that I've been using for a while now, and I hope you're using as well. So I'm going to run this in this mode up here where we can see this canvas pop up and go through step by step and see the objects appear. So I'm going to see if I can get everything to appear here where we can read what we're doing. So we're going to run line by line. We're going to create our array list. Step down there. Now we have our array list object called all accounts. Pop it up here. And in the beginning, okay, here's basically an empty array list. That's why we have nothing down here. We're going to be filling in some boxes here as we go. Okay, and then we create a checking account object called Joe's checking account. And we do a little bit to add some money to it and withdraw money, and then we add it to the array list. So I'm going to show you what that looks like. I'm going to go down and add that to the array list. So what we just did is we created this object here, and I can actually drag that out and see what it looks like. Okay, this is the checking account object for Joe's checking account, and we added that to the array list. So here it is. Here's the object. And it's being referred to by a variable in the array list, which is a checking account type reference. Okay, that's what this pointer is right here. That's the same thing as we've been drawing all along. The reference variable is here. It's referring to the location in memory where this object is stored. Okay, so I'm going to keep stepping through and show you that the same thing happens here now for the next object. So we just added a rewards account object now to the array list. But if I click and drag this down, you'll see that this has extra data because it's a rewards account, right? So it's got a monthly fee and some points. So that is the object that's stored right there. And then we've got another checking account being created here. Okay, so we got that third object. Now I'll go grab that and pull it out. And we'll only have 3 data elements because it's a basic checking account. Okay, so this is the picture we just had. We've got 3 objects of different types, but the actual references that are referring to them are of this type checking account. Okay, and we're okay with that because we know that the checking account class, actually all of its methods only really need to refer to these 3 variables, these 3 variables, and these 3 variables, so we won't have any problem. Any method we can call on this type of reference will have access to the data that it needs. So here's the part now where we actually see how all of this is very, very useful when we want to store things in lists that have multiple types of objects. And we're going to go through now and we're just going to iterate over all of the objects in the list and call print account info. Okay? So I'm just going to start running this, and this is hopefully as we do this, this will make sense how this is an example of polymorphism in action and how polymorphism is very, very useful. So keep in mind, this is kind of a little toy example where we just have 3 accounts. But imagine, again, a real application at a real bank where they have thousands of accounts, okay, of varying types. And we want to just do something like this, where maybe at the end of the month, we're printing out all the account info for all of the accounts. Okay, we want one nice central place where we can just do something simple like this, write a loop to go through all of the accounts in the array list and just print out the account info. But what we want to have happen is we want the appropriate version of this method to be called based upon the type of object. So let me show you what I mean. Let's just start running this. So I'm going to step through. I'm just going into a loop that's going to go from 0 to 2, essentially, because it's going to go through the size of the array list. Okay. And what I'm going to do is I'm going to get each of these objects out. I'm going to pull each object out into a variable here called account, okay? Because I'm going to use that object. So I'm going into the array list. I'm at I equals 0. So now I'm going to get the object at 0, which is that one right there. I'm going to step down through and show you that now account now holds a reference to that object or this one. So if I actually grab account and pull it out here right now, you can see that it contains all the information for this object. Okay, this is important to understand. I've demonstrated this before, but I hope that makes sense. Account now has a reference to that object right there, which I'm showing here. Okay, so account is now basically referring to the same thing that that pointer right there is referring to in the array list. So I've got a hold of the first account, and now here's the important part. I call print account info. So the question is, which version of print account info is going to get called? Because I've got two versions. If you remember, we overrode that method. We had print account info down here, and we have another print account info here in the rewards account that prints out all of this info plus the number of points. We could have added the monthly fee in there too, but we didn't. Okay, so there's two different versions of print account info. So which one is going to get called? Well, I think in this case it makes sense that for this object type, which is the one we got a hold of, we've got it right there, it's only going to print out the three variables, right? It's going to call the type in the base class. Jump back again into the checking account. It's going to call this version that just prints out the owner, account ID, and balance. And that's exactly what will happen. If I go back to our program here, one more step, maybe get all this in here. Let's see if I can zoom out a little bit. You can see that it is printing out just those three pieces of data. So it did call the method from the base class, which makes sense because this reference is a checking account and the object it was printing out was a checking account. So here's where things get more interesting and become much more useful for doing something like this. Again, imagining this example where you have a big bank with thousands of customers. So if I go down here and I step one more time, okay, now I'm on I is equal to 1. Okay, so I've iterated through my loop, so now I'm getting a hold of that object right there, which is this one. And you can see that that's exactly what happened. Now account is now referring to all accounts get 1, which happens to be this object. So here's what account is now referring to. Okay, and again, that's what that little pointer means there. It means it's a reference. Account is referring to this object in the heap. Okay, and it's got a hold of all of this data, including points. So here's the interesting thing. Which version of print account info is going to get called now? Okay, we've got two versions again. We've got the base version for a checking account class that only prints out the three variables, and then we've got the derived version that prints out four variables, including points. Well, obviously what we want to have happen is we want it to print out all the variables, including the points, because this is a rewards account. But our reference variable is of the type checking account. So you would think, or I think most people would guess, that when we say account, ACCT, which is a checking account, dot print account info, most people would say, well, that's calling the method from the checking account class. So again, if we go back to that, we'd think it's calling this one. It only prints out the three things. It doesn't include the points. But watch what actually happens when we run this line. And this, again, I don't know if this is, hopefully this is making sense, how this is very, very useful. But when I actually step, notice what it actually did. It printed out the version from the subclass. It printed out the points, which is exactly what we want. If we have thousands of accounts in our bank and we want to run this report and print out all the data, we want to get the data for whatever the type of account is. We want to get the points that that person has or whatever important information is in there. So it actually ran the print account info from the derived class. In other words, even though the reference variable that was referring to it was a checking account class type, Java figured out that the actual object that was referring to was of the type rewards account, and it figured out, okay, I'm not going to go call the method here that's actually in the checking account class. I'm actually going to go to the class that has the version of that method that's actually for the specific type of object that it's actually referring to. Okay, again, this is a little complex, but hopefully that makes sense that that's very valuable. Okay, and that's what it's actually doing. It called the method for based upon the type of the object, not the type of the reference. And this is where I'm going to jump back and show you, if I can get to it. Let's see if I can get this to pull up here. For some reason, there we go. I added a little more data, or a little more text to this little couple of phrases I showed you earlier. And this is the important thing to know about all of this. Okay, it's a little wordy, but hopefully with this example, this can make sense. And this says that when we're dealing with situations like, let's see if we can get this to pop back up here. Yeah, there we go. We're dealing with situations like this. where we're assigning one type of object to another type of actual reference variable. The reference variable, this type over here, the type of the reference variable determines what methods can be called. Okay, and only the methods from that class can be called. The object type determines two things. One, what data actually gets stored, so how much data is stored, like all of the variables here. But probably more importantly, this is the new part, the object type, the type of the actual object that's being referred to, determines which version of the method gets called. Okay, so that's what we just saw. In our code, when we called print account info on this type of object, which is a checking account, it only printed out these three variables. When we called that same method, okay, which has two versions, on this type of variable, it figured out that it needed to call the version that prints out the points. So it's the actual type of the object, each object that's being referred to, that's determining which version of the method gets called. Okay, so this applies to these overloaded methods. When you have more than one version of the method, the actual type of the object that's being referred to is the thing that determines which version of the method gets called. And that's what enables code like this to happen. So it enables code that actually adapts. It's this polymorphism where one version of this method was called for one type of object and a different version of the method was called for a different type of object. And again, hopefully this is clear, but look, we didn't write two different versions of the method in the code that actually is running. This is the method right there. That's the code that ran to print both of these. It's the same exact method. Okay, we didn't write two different calls, two different types of method calls. We wrote one method call and it adapted. It used polymorphism to figure out which type of object it was being called on to know which version of this method gets called, and it ran the appropriate one. So it gave us all the details we wanted for the type of object that had the points in it. So let's just finish this off here, and hopefully this is making sense, or at least some sense. Okay, again, I know this is complex. But if I go down through and do it for the third type of object, which was once again a checking account, okay, Sue's banking account right there. Okay, again, it figured out which version of the method to call, and it called the one that actually only prints out these three variables and doesn't include the points. Okay, so that's what all of this polymorphism, this example is about as good example as I can find for doing something fairly simple, where you can see that you take objects of different types, derived class, base class. You put all of them in an array list that can contain, it's listed as a reference type of the base class, but it actually can contain objects of both types. So you can have this mixture of both of those types of objects. And the great thing then is that in the end, you can iterate over all of those objects, and when you call methods on them, the appropriate version of the method would be called. The whole point. It's not limiting. It's not saying, well, since we said that these were checking account objects, it's only when it calls print account info, it's only going to print out the owner account ID and balance. No, it's going to adapt. It's going to call whichever version is appropriate for the actual object that's stored in there, and that's what allows us to create all of these programs that store lots of different types of objects and still have code that we can write that will behave appropriately for whatever type of object was actually in that list.